Good morning, everybody. This is Mr. Enyart, and this is your morning work for Tuesday, week 28. All right, IQR, interquartile range. That means we don't care about the maximum, we don't care about the minimum. What we care about is what's within the quartiles. And we're going to take the greatest quartile minus the smallest quartile. So that's just 8.0 minus 4.5. Can't do 0 minus 5, so it becomes a 10. Drop your decimal. So the interquartile range is 3.5. For number 2, again, minimum and maximum are irrelevant for IQR. We're going to simply look at our quartiles, take our biggest quartile, quartile 3, and subtract quartile 1. And so we're going to have 25 and 5 tenths minus 17 and 0 tenths. Drop our decimal, can't do that. That's 8, 8.5, or 8 and 5 tenths. So IQR has a formula. You may want to write this down. IQR equals Q3 minus Q1. That is the formula for interquartile range as practiced today and yesterday on Monday's morning work. All right, so using the histogram, which I just took a picture of it and stuck it here, we're looking for at least 136 centimeters tall. So again, the language here says that it can be at 136 centimeters, right? But then it must be greater than 136 centimeters as well. So we're looking at all of these. Sorry, it's a little under the gray there. Let's try that again. Voila. All right, so the question is how many girls are within those marks between 136 and 145, since they can't be 135, right? They cannot be 135 because that would not be at least 136. So we're looking at 14 for the yellow and 3, which is 17 girls. So here we have a straight up 70% of something is 14. So if I just use the tape diagram, all right, we're going to show cross multiplication too because that's the big thing they're working on. But I want you to understand what that means. That means a portion of something, which is this purple section here. This is my total amount, all right, and a portion of it, this chunk, is 14. So where would I put X on my diagram? It's going to be on the bottom. Would I put it here, here, or here? I would put it at the end because X is my total, right? X is the whole amount, just as 100% is the whole amount. But it says that 70% of that whole is 14. So where would 14 go? 14 would go right where 70% is at, which means this is 0. 14 would go up here, 70%, right? And so now using my tape diagram, you can see that in the purple, I have 7 rectangles, 7 equal rectangles that equal 14. So what would they all have to be? What's 14 divided by 7? They all have to be 2s, don't they? Which means so do these. So X is a combination of 10 2s. So X has to be 20. So if you did 70x equals 1400, you're going to divide both sides by 70, which cancels it out on the left. Divide this by 70, so it's 140 divided by 7. Remember, 14 divided by 7, zoom in on that. 14 divided by 7 is 2. And then you've got this 0 to throw down here. So you still get X equals 20, whichever way you choose to do it. You tell me which way you like better, and you do what works best for you. There you go. And I realized in the last video I showed you a different way, which is to write the simplified version of the fraction, which is 7 tenths equals 14 over X. And you can just see, to make equivalent fractions, this is times 2. So this is times 2. So X has to equal 14. I'm sorry, x has to equal 20, because it'd be 10 times 2 to get x, just as it was 7 times 2 to get 14. So 7/10 is 70/100, which is 70%. And 14 is of a total we don't know. So since 70 is 14, we can say that the 7, the simplified version, is equivalent to 14 by using times 2. And so I can do the same thing down here. And that works as well. Okay, so to find the mean, we add up the 4 numbers and divide by how many there are. And to find a MAD, we figure out how far each number is from that mean. So here we have 9, here we have 19, and that gives us 28. Divided by 4 means our mean is 7. Okay, everyone get that? So now we're going to figure out how far is each number in our data from the 7. The 2 is 5 away from 7. The 7 is 0 away from 7. The 9 is 2 away from 7. And the 10 is 3 away from 7. So now we add those up and divide by 4 to find our mean of our absolute deviations. So what's 5 plus 5, which is 10, and 10 divided by 4 is 2.5. So our mean absolute deviation is 2.5. All right, so 6 and 7, you'll find this information in Module 5 of Eureka Math. If you're in that, there's some videos popping up on Edpuzzle, FYI. But area of a parallelogram, it's Module 5, Lesson 1, I believe. I really break that down as to why this works and why you need to know that the diagonals don't matter in parallelograms. This side and this side, they don't matter. All we care about is the base, which is the bottom, and how tall it is. Straight 90-degree height. A height has to be 90 degrees from the base. Because when you multiply two numbers, you create a rectangle. And a parallelogram is not a rectangle because it doesn't have right angles. But by finding the exact height from bottom to top, which is not equal to the diagonal lines, it's not equal to these. The height is a different amount. You can then just multiply length times height. We call it base times height, or BH. So the area of a parallelogram is base times height. So we're just going to multiply the 12 times 9. We're going to get 108, and we're going to say units squared. So on this one, again, here's our base, and they did give us units, meters. Here's our height, right? The height is 90 degrees from the base, shown by that angle. They didn't even mark the length of our diagonal sides that come off at a non-90 degree angle because they don't matter in a parallelogram. What matters is the height. 7 times 2, base times height is our formula, right? Base times height is the formula for a parallelogram. 7 times 2 is 14, and so our units are meters squared. The distributive property would have you writing 10 times 1 plus 10 times 2, which is going to be 10 plus 20, which is 30. Now, if you just do 1 plus 2 and get 3, and then multiply that by 10, you would also get 30. But this represents the distributive property because you're distributing the 10 times the 1 and the 10 times the 2, and then you're adding those together. Okay, so to find equivalent fractions is to multiply both numbers, the top and the bottom, numerator and denominator, by the same factor. So I'm going to start with times 2, then I'm going to move to times 3, then I'm going to do times 4. So 3 times 2 is 6, 4 times 2 is 8. 3 times 3 is 9, 4 times 3 is 12, 3 times 4 is 12, 4 times 4 is 16. So 6 eighths, 9 twelfths, 12 sixteenths are all equivalent to 3/4. And the last question is a simple, we should be able to do in our head question, but I'm going to show you the questions that you can ask yourself to figure this out. But we know that t-shirts are on sale, right? We see sales all the time. Sales are great. For 20% off, the original price of 20 bucks. So the original price is $20. We want to know how much is taken off if 20% is taken off. So the first question we ask is, what is 20% of 20? Right now, doing that in your head may seem a little challenging, right? Even though 20% is twice of 10%, so you could do 10% of 20 is 2, 2 of those would be 4. However, my next question that I always go to is 20% is one of our benchmark percentages, it's 1/5. So I'm asking, what's 1/5 of 20? Right? And to find a fraction, a unit fraction of a number, you can divide that number by the denominator. Aren't we literally trying to figure out what 20 is broken into 5 pieces and what one of those is? So what is 20 divided by 5? 4. So 20% of $20 is $4 taken off each time.